So last class we learned about how to graph the basic sine, cosine, and tangent functions. In this class, we're going to learn how to transform them. So it's worth kind of recapping that basically these are all types of periodic functions, and periodic functions are functions that repeat in regular intervals, and those are called cycles or periods, right? And trigonometric functions are periodic, and the period is actually the word for the length of the cycle. So how far it is between a common point, like either like maximums or minimums, etc. That's really important to know. And then also that an amplitude is how far away the maximums or minimums are from the midline. That's not really written on this paper, but basically there's a midline that represents the middle, and the amplitude is the distance. Basically, it's the half the distance between the maximum and the minimum values, but that also is another way of saying the distance from the midline to the max or the midline to the min. Right, and we already kind of went over sine and cosine functions. You graph two great periods of those, but what I just kind of want to do is just show you on a graph what's kind of going on and kind of my way of remembering it. The sine function starts with an amplitude of 1 and a period of 2 pi, which is why you went ahead and graphed for me from negative 2 pi to positive 2 pi to show me two whole periods, right? That would be 2 times 2 pi, so 2 periods of it. And the sine curve, kind of the way I remember it, I kind of think of it as starting on the, at the origin. And so it starts at the middle value, and then it goes up to its maximum by pi over 2. And then it goes back to its middle value at pi. That's where it's equal to 0. And then it goes down to its minimum value, which is negative 1 at 3 pi over 2. And then it goes back to its middle value again at 2 pi. Right, and we could kind of go backwards and model this backwards if I went in the opposite direction. And so then we get like a pretty good little sine curve. So I know that last time you did 2 periods of like every single value, which is really helpful to kind of get used to the function. But we can kind of boil it down to, as you'll hear me say, mid, max, mid, min, mid. And this is just kind of my way of remembering the pattern as it pertains to starting at the origin, right? And then the amplitude is how far away it goes. And since we know the sine and cosine, the biggest value is 1 and their smallest value is negative 1. They're both 1 away from the middle. They're also, you can kind of think of it as, max minus min divided by 2. So basically 1 minus negative 1, that's supposed to be. 1 minus negative 1 divided by 2 would also give you back 1 for that period value, that amplitude value. The cosine has a little different a pattern in my mind. It starts at its max, goes down to its middle, then down to its minimum, back to its middle, and finally ends up on its max. And so we can kind of trace this backwards as well through the negative period. But basically, they look really similar. It's just kind of where they start and where you kind of jump on the pattern. So as we did that last class, right? So that was just kind of all a review. But basically, now we're going to start changing some values. So we're going to start playing with a number in the front, and that value is going to tell us the amplitude. The amplitude is always a positive number, so it's the absolute value of the number in the front. And the period is going to be 2 pi divided by b, right? So what's going to happen is if there's no number in front of the theta or in front of the x, the period is just 2 pi. Oh, I wrote 2b. Let me rewrite that. It's 2 pi divided by b. But if there is a number, then that's going to change the period, which means the space in which our graph has time to complete its cycle. So just first of all, let's kind of identify what would the period of this first one, the amplitude of this first one be. It's just that middle number, that starting number right in front of the function. And then our period is going to be 2 pi divided by the value of b, and b is right in front of your theta or your x, your variable. So in this case, it's 2 pi divided by 2, which means the period of this equation, 3 sine 2 theta, is just going to be pi. All right, next one, my amplitude once again, just the number right up front, so 3 over 2. Period is going to be 2 pi divided by the b value, which in this case is a third. So I'm just writing, whenever I deal with fractions, I kind of write it out old school way. So then that becomes 2 pi times, and I have to reciprocate it. And so I get 6 pi. All right. Now let's kind of see how that would change those graphs, right? So let's, like, next one. The period is not going to be changed because this value in front of the variable is just 1. So 2 pi divided by 1 would just be 2 pi. But the amplitude is going to be that number up front, that 4 value. All right, so what does that mean? That means my sine, which normally varies by 1 above and below the middle of the graph, is now going to vary by 4. So it's still going to follow that same pattern, right? And now where do I get these points from? They always seem to be at the ones that are marked, but let's just kind of talk about it. My last location on the x-axis is 2 pi. Then I'm going to always take that and have it. And it's not always going to be 2 pi, but it's 2 pi because of the period is 2 pi. Then I'm going to take it and have it. And so that will give me, I need to make a point at pi. Then I'm going to have that, which happens to be at pi over 2. And now I know I'm counting by pi over 2. So I have 1 pi over 2, 2 pi over 2, and then the next one is going to be at 3 pi over 2. And this one happens to be labeled, but they're not all going to be labeled. And so it's important to actually kind of go through those steps with yourself. Plus, I could always just give you just a plain x-axis with no labels on it, and then you would have to come up with those labels. The 4 denotes that we're actually going to move 4 above to make our max and 4 below. Now, we're not going to mess with all different kinds of transformations. We do that in other classes. But basically, if we did shift this entire graph up, that would change that max and that min value. But right now, we're not going to kind of mess with that. We're just going to keep it at 0 as the midline. And so we're just going to change these two values. That's more of a college algebra 2 thing. All right, so we're going to follow that pattern. We're going to start in our middle, which is going to be at 0. Then we're going to go to our max, back down to our middle, down to our min, and back down to our middle. Let's kind of model that all the way on the other side. We're going to go down to our min, middle, max, middle. So as you can see, hopefully you can tell the difference is that this graph goes much higher, right? And so this is what happens when you change the amplitude. You can change how high up or how low down it goes, right? So it can either be really short or really tall. All right, same thing. Let's try this for the cosine over here. For this one, we're modifying the b value. So we have a normal number up front, so that's just going to be a 1, right? I filled in the 1. We don't normally do that, but we can. So this guy's going to change that b value, how we label that x-axis. So my period is going to be 2 pi divided by the b value, which is 1/2, which really means 2 pi times 2, or 4 pi. All right, so that means really, if I was kind of doing this, I'm going to need 4 whole pi to get a whole period, right? All right, well, I don't have 4 pi on the right or just the left. I have them together, 4 pi. So let's kind of think about how you could do this because it's pretty important. Normally, we would start at 0, and we would go from 0 to 4 pi. And then I'd have you do that little trick I just said. Divide it in half, 2 pi. Divide that in half, pi. That is what you're going to count by. So the pi's are where you're going to put points. So we're going to put a point at 0. We're going to put a point at pi. We're going to put a point at 2 pi, but we can't go any further. So we're going to have to go back to negative pi and back to negative 2 pi. So we're going to have to get a little bit creative here. All right. Our amplitude hasn't changed, so our maximum value is going to be at 1 and our minimum value is going to be at -1. So those kind of always keeping the same for this one. All right, so our cosine usually starts at its max. So at 0, it's going to start at its max. And then it goes to the middle. So over here at my next tick mark on pi, it will be at the middle. Then it will go down to the minimum 2 pi, which is -1 by the time we get to 2 pi. I don't have any further I can go on that side. So now I kind of have to go back and be like, all right, well then it would, if it was at its max at 0, then at negative pi, it would be at its middle. And then it would be down here at its minimum. So now you can see that we have one long and skinny, like long and short, not really skinny, very wide looking cosine graph. So that we've got one period of that. All right, let's see what happens when we do both of them. So let me do number 5. So in this one, we have a 1/2 up front, 1/2, and we have a period of, well, we have a b value. This is my b value of 3. So 2 pi divided by 3 is going to be my period. All right, that's kind of annoying. So what I usually do is I take the 2 pi over 3 and I actually divide it in 4, because that's what I'm doing over here, where I divide 4 pi and, in 2 and then in 2 again, right? You divide in 2 twice, you're dividing it in 4. So if my period is 2 pi over 3 and I divide that by 4, I'm actually going to have 2 pi over 12, right? We can all do that in our heads. Or basically pi over 6, right? That simplifies. So every pi over 6, I'm going to need to make a mark. So, all right, we know that there are actually 3 pi over 6s in pi over 2, right? So pi over 6 is going to be smaller than a quarter, right? So it's going to be like right here, and then there's going to be another one right here, and then pi over 2 will be another one, because that would be 3 pi over 6s, which is a half. And then we're going to have 4 pi over 6s, which is our last one, and 4 pi over 6s, which is obviously 2 pi over 3. All right, so we've got this tiny little period that we're going to have to work on, and we're only bouncing up and down between a half and a negative a half. All right, so this is our cosine. I'm going to start at 0 at the max, move to the middle, move down to the minimum, move back to the middle, move back to the max. And so it's this tiny little graph. Now we can keep doing that, right? We can keep going by thirds. We ended up at 4 6s. So then we would have 5 6s, and we would have 6 6s, which would be pi. And then we'd have 7 6s, which would just be past pi. And then we'd have 8 6s, which is 4 thirds. So that would be right there. And then we'd have 9 6s, which is 3 pi over 2. So we could keep going if we wanted to, right? We're going to go back from our max, middle, minimum, middle, max. We'd have another one, and we keep going on and on and on like that, right? So I'm not going to keep doing all the tiny little ones, but you kind of hopefully get the idea for that. All right, how about my next one? We got an amplitude of 5 and a period of 2 pi divided by a third again. So that's actually 2 pi times 3, which is 6 pi. Which is ironic because we're not even going to be able to see the whole period here, right? My axis is only going from negative 2 pi to 2 pi, so I can really only see 4 pi, so I won't even see the whole thing. All right. Once again, I think it really helps to divide that in 4 so that you know what you're going to mark by. So if I divide it in 4, I'm going to be 3 pi over 2, 3 halves. So if I have like a point at 0, I'm going to need another point at 1.5 pi, right, which is right here. And then another one at another 1.5 after that, which would be 6 halves, which I don't have, right? So I don't have 3 pi on here. And so I can also go back negative 1.5 pi, but I don't have another one. So now you see kind of why I won't have enough space. I'm also got an amplitude of 5. So for my sine, I'm going to draw my dot here, right? But then I'm going to go all the way up to 5 for my max. And then, because normally sine would go middle, max, middle, mid, min. And then all the way down to 5 over here for my minimum. And so this graph is going to kind of look something like this. All right, I hope that kind of makes sense to you. There's a bunch more problems to practice with. We try not to do too crazy things. And I will say, if you are struggling with the x-axis, like sometimes it's just better to draw your own. Like for example, let me do like this number 10 really quickly for you. I'm going to draw my own x-axis. And most people get much better at it when they draw their own. So 2 pi divided by 3 halves would make 2 pi times 2 thirds, or 4 thirds pi. Whew. All right. So like I said, that would be the end of the period, right? 4 thirds pi. 4 pi over 3. I'm just kind of spacing it out so I've got some space. And then so what I tell students to do is to divide that by 4. 4 thirds, sorry. Divided by 4. Which basically becomes times 1/4. So I'm going to mark off by pi over 3s. So we're going to basically add a pi over 3, 2 pi over 3, 3 pi over 3, which is a pi, so we would simplify that, and then 4 pi over 3. That's where we're going to mark on that x-axis. And then here we have our max at 2 and our min at -2. So then we would go ahead with the cosine. We would say max, mid, min, mid, max. And so you can see it's kind of easier when you just label your own x-axis because you don't have to, you're not trying to estimate where the numbers actually go. All right, tangent's not so bad either. Tangent had that thing that sine and cosine didn't. They had values where we got DNE or undefined, right? And those created those vertical asymptotes. And these vertical asymptotes happen to be at pi over 2 and negative pi over 2. And then in between those, we go through 0, and so we kind of go from low to high right up here. Now, tangent also has an amplitude and a period change, right? And where theta is in radians. The period, because tangent just repeats over and over and over again, right, in between these asymptotes that just kind of also repeat as well. We really want you to sketch in those asymptotes just to kind of keep that in mind, right? So the period is actually just pi divided by b, right? And rather than 2 pi, it doesn't start with a period of 2 pi, so it's just going to take pi and divide it by b. The asymptotes are odd multiples of pi divided by 2 times the absolute value of b. So if we need to refine those asymptotes, we can. I have another way that I kind of like to think about it, and I'll show you that way as well. All right. The amplitude is also discovered by A, right? But the thing is that because the tangent just represents, all of the points from basically negative infinity to positive infinity, right? It goes down forever and up forever. Changing the amplitude really doesn't change the way the graph looks that much. It might go up a little faster if the amplitude is huge, or it might go down up a little slower if the amplitude is not. But it doesn't really do too much, two things, nothing really exciting like it does with the sine and cosine graph. All right, so this guy right here, its period is at pi, right? And so what I do is I take that period, pi, and I divide it in half. And I know that at 0, tangent is 0. And so literally I take the period and I divide it in half, which gives me pi over 2, which means on either side of the y-axis, pi over 2 away, there has to be an asymptote, right? That's kind of the way I remember it. And then I just go ahead and then, yes, the amplitude is 2, which could give us like some good points, but basically that's going to make it pretty steep, right? Because it's got 2. And so kind of every pi over 2 now, well, actually, now pi away, right? So don't forget, has to be a pi distance in between these guys. There will be another asymptote with a 0 in the middle. There you go. So that's kind of a good graph of that one. Now, what happens when I go ahead and I change that period? So let's say right here, we've got our b value of 1/3. So we've got pi divided by 1/3, which really means pi times 3, or 3 pi. So same idea, I take that and I split the 3 pi on either side of the y-axis. So if I divide 3 in half, 3 pi over 2 divided by 2, 3 pi divided by 2, you get 3 pi over 2. So literally, I'm going to have an asymptote over here at 3 pi over 2 and one at negative 3 pi over 2. In the middle, tangent is going to be 0. Right? And then over here to the right, it's going to go up. And over here to the left, it's going to go down. So that's kind of generally what that looks like. And so I think that's a little bit easier. But, hopefully that makes sense to you guys. All right. So once again, let's kind of change both of those. We've got a b value of 2. So if I take pi and I divide it by 2, I get pi over 2. That's kind of small. But if I take half of a half, right? So if I take my pi over 2 divided by 2, I actually get pi over 4. So that means over here at pi over 4 and negative pi over 4, I have asymptotes. And then another half a pi later, so over here at basically 3 pi over 4 and negative 3 pi over 4, I've got another set of asymptotes. In the middle of all those asymptotes are zeros. And on one side it goes down, and on the other side it goes up. Now when you have it really steep like this, it's hard to make it bend. Just do your best to try to make it bend a little bit so it doesn't just look like you're drawing straight lines. All right, I hope that makes sense.